we have to find the moment of inertia of this disk about this tangent. The mass of disk is m, the radius is r. So when we have to find the moment of inertia, so various options we have is, first is if that is a particle, we can directly do m into r square and we can find the moment of inertia. If this is system of particles, then simply we can add it. If this is a continuous mass distribution, we know some results. Let's say for disk, ring, solid sphere, etc. we know it. Then using that, now we have two options. One is we can use for parallax theorem or perpendicular axis theorem or both. And if still that doesn't work, then we can use the basic concepts of integration. We know when the disk is there, we know that is the moment of inertia of this disk about this axis is, that is, if I say about this z-axis over here, that is z is not here, we are taking z over here, that is m r square by 2. That is, we know that suppose this is a coaster, I have taken it as a disk, and this about this axis, it is going to be m r square by 2. That's right, we know it m r square by 2. If this is m r square by 2, then about any diameter, be it this diameter, be it this diameter, be it this diameter, about all the diameters, it is going to be I only. We have done it earlier also. So if this is I, about this is I, and about this is I, and both the axes, they are perpendicular to each other, and this is a lamina, this is a two-dimensional body, thickness is almost equal to 0. So we can use perpendicular theorem. It means Ixx plus Iyy is equal to Izz. Izz, we know it is mr square by 2. Standard result, we know it. So I plus I, 2i. So 2i is equal to mr square by 2. We have done earlier also. So for this, I is here, about this is I, and about this is also I. So I plus I, that is perpendicular, using perpendicular theorem, this says 2i is equal to mr square by 2. So I is equal to mr square by 4. So we know that is moment of inertia about this axis is going to be mr square by 4, right? And what is this? This is ICM only. What we have done? We have made use of perpendicular theorem. Now we have to find the moment of inertia about this axis. Obviously this axis and this axis, they are parallel to each other. Now we are supposed to find moment of inertia about this axis, right? Had it been this axis, then it is simple, that is mr square by 2 about this axis plus mr square. So we can directly find mr square by 2 about this axis, and if about this axis we have to find out, so we can directly use parallax theorem, mr square by 2 plus mr square, that is 3 by 2 mr square, that is we could have got it. But our axis is like this. So what we do is, first using perpendicular theorem, we find the moment of inertia about this axis, which comes out to mr square by 4. Now this axis is passing to the center of mass of this disk. So now we can very well use the parallax theorem, because in parallax theorem, both the axes, they have to be parallel, and one of the axis, this axis, it has to pass through the center of mass. So moment of inertia about this is mr square by 4 plus m into the distance between the two is r, so it is mr square. So we can say that is Iyy dash is equal to ICM plus m into this distance. What is this distance? This is equal to r. So that is equal to mr square. So that comes out to be mr square by 4, that is ICM plus mr square. So that comes out to be 5 by 4 mr square, that is moment of inertia of this disk about this axis. So this is kind of a question where we are making use of parallax theorem as well as perpendicular axis theorem to reach the result.